boundary value problem. So for boundary value problem, what we have a standard form, that is second order linear differential equation, a second order linear differential equation. That means what is second order? The y double s plus px of y dash plus qx y equals to rx or phi x, we can say rx or phi x, whatever we can say, right? So this is the differential equation in which we will discuss boundary value problem. And the boundary conditions are boundary conditions. So what type of boundary condition will be given? Boundary conditions will be alpha 1 y1 y of alpha plus beta 1 y dash of alpha is equal to gamma 1, and alpha 2 y of b, say this is a, okay, and this is a, and this is alpha and this is beta, right? This is a plus beta 2 y dash of b is equals to gamma 2, right? So this is the boundary condition. So what we have, this p and this q should be continuous, px and qx and phi x are continuous in AB, and these are constant, these are belongs to gamma i's, alpha i's, beta i's, and AB belongs to R, so real numbers. So that's it, that's the problem. So and also that alpha 2 and alpha are non-zero, we have to assume that this alpha 1 non-zero, this beta 1 non-zero, because gamma 1 can be 0, but if these two are 0, then we cannot get any solution, right? So condition. So what we have to do, what we have is that these two cannot be 0. That means our beta 1 and alpha 1 cannot be 0, and alpha 2 and beta 2 cannot be 0. So these two cannot be 0, so that our condition is solved, right? So similarly, the boundary condition is homogeneous if the both differential condition homogeneous. That means phi x should be 0 and this is 0, this is 0, then we'll say that this is homogeneous, this is homogeneous condition. If it is only this one is 0, then we cannot say this is homogeneous, but along with that one, these two must be 0, so that we can say it is homogeneous. The boundary problem, okay, is otherwise if any at least one of them is non-zero, then we'll say non-homogeneous. So it is easy to notice that, or something we say notice, we can have to notice, if 0 then homogeneous, otherwise non-homogeneous, simple as we think, otherwise non-homogeneous, right? So so how does homogeneous boundary value problem will look like? How it will look like? Y double s plus px of y dash plus qx of y is equals to 0, subject to y of f, y of a, alpha 1 cannot be 0, beta 1 cannot be 0, y dash of a is equals to 0, and alpha 2 y of a plus beta 2 y dash of a is equals to 0. So this is our homogeneous boundary value problem, right? So that's it. Now this is a homogeneous boundary value problem. Another case, what we can say from here, that yx is equals to 0 is always a solution. So in boundary value problem, where the system is homogeneous, then yx is equals to 0 is always a solution. So that's it. So so how to obtain the solution of a boundary value problem? It is simple. If we want to obtain the solution of a boundary value problem, then what we have to do, we know that this is second order differential equation, linear differential equation. So we have to first solve them. After solving that, we will get the solution, and after getting the solution, we have to apply these two conditions, right? These two conditions in homogeneous as well. So after that, we will get certainly the required solution. So from here, what type of question they may ask? Find the they will give the linear differential equation, and with condition they will say find the condition for unique solution. They may ask unique solution, or they may ask find the condition for infinite solution. So this type of question may arise from this boundary value problem. So this is our case. Now we'll proceed further to know whether how to find these solutions, right? Now what is our problem? Y1 and two linearly independent solution, then let y1 and y2 are linearly independent solution, then non-trivial solution to the exist if and only if, then non-trivial solutions to the homogeneous boundary value problem exist if and only if the determinant alpha 1 y1 a plus beta 1 y1 dash a, alpha 1 y2 a plus beta 1 y2 dash a is equals to 0. That means alpha 2 y1b plus beta 2 y1 dash of b and alpha 2 y2 of b plus beta 2 y2 dash of b is equals to 0. This should be 0. Then only we can say we can say that non-trivial solutions to the homogeneous value problem exist if the determinant is 0. The value of that determinant must be 0. Then we say that the solution exists. Result 2. Homogeneous has exist not identically equal to 0 to the non-trivial solution. So for non-trivial solution, the determinant of this value must be equals to 0. Result 2. The non-homogeneous boundary value problem defined by 1 and 2 has unique solution if the associated homogeneous problem has only the trivial solution. Boundary value problem unique solution.